think it's not that the whole matrix is random, but that the pairwise scores are chosen at random. Okay, and calculate this quantity, this consistency index for each of those, and then take the average of those as being sort of representative of, you know, this is the consistency index of a random decision maker. And then so that value depends on n. And so you can look up tables that give those values. So, for example, for n of 3, that constant is 0.52. Okay. So if we have an n of 3, we would take our consistency index, divide it by 0.52, and that gives us the consistency ratio. And the general rule of thumb that people use is that if the consistency ratio is less than 0.1, then that's okay. Then, you know, it's still, you know, if it's, yeah, it's still the weight vector still is a reasonable representation of the person's preferences. If it's larger than that, then, you know, what that really says is that the person's preferences, or whoever's preferences, are so inconsistent that basically the assumption of rationality starts to break down, and anything you do with these numbers is just.
And what is the value of 1.2 actually called?
It is called. The comparative value. So if we look for, so it tends to increase with n. The first few values are 0.5 to 0.89, 1.11, 1.21.
That just literally comes from running a bunch of simulations with random.
Yeah. And as far as I know, I mean, you know, that was done once long ago, and these numbers have become enshrined. So, I mean, you know, in principle, you know, you could imagine there have been some other criteria proposed for ways of comparing the consistency index to something random, but they all seem to give pretty similar results. And, you know, likewise, I don't know what the history of this 0.1 threshold is. I think it was mostly developed to give results that seem reasonable. Okay? So it's not like a hard and fast rule. It's just a useful rule of thumb. So there's a few other things that we could talk about. Maybe we'll talk about them on Thursday. So on Thursday, we'll actually run through an example using some Excel software. I've posted several readings. This chapter by Sati is long. You probably don't want to read the whole thing, but the first few pages really kind of give you the psychological, philosophical underpinnings of why AHB is done the way it is, and why he thinks that ratio scales are the right way to measure preferences. This paper by Duke and Alt-Hyde is an interesting one where they've used AHP as basically to elicit public values. So they use it as a survey in a survey context to ask people about different. So their focus was in purchasing development rights from farmland and natural land so they're trying to understand what aspects of the potential benefits of these programs people actually value. So they're looking at things like, how do they value keeping land and agriculture, right? And they have a bunch of subcategories for what various things, various benefits of having agricultural land around. What are the benefits of having natural land? I mean, how important is having natural land for you? What are the subcomponents of that? What are the importance of just having open space generally, or preventing preventing sprawl? Okay, try and understand. They didn't get the question of how much do you value this relative to other uses of the land, but they were trying to at least understand how what aspects, what benefits people actually cared about as compared to what policymakers might have been. And this last one, just